Now, in this episode, we're making a little spacer block for the lift pump on a flathead Ford. Now, as you can see, this is slightly different from any normal flathead, if you know these engines, in as the distributor is at the back. And the German WW2 engines were made like this. The Germans has also incorporated metric threads rather than imperial that the originals were designed with. So these spacer blocks are just not commercially available. Now, these original blocks were plastic on the engine, and as such, I'm not going to go into too much CAD work detail here, in fact none. This is the component we cast, but I've done 3 versions of it because we had 3 different strategies as how we were going to tackle this. But this particular version for the casting also had a riser, which I'm designing here, and in hindsight, as a casting point of view, it was a good thing to put a blind riser on, and to be fair, I probably still would doing it now, but the tags here that I designed to help hold the component down were a bit pointless. Well, they were pointless actually, totally pointless. But the basic idea here is the blind riser helps feed the component as it cools down to stop any shrinkage. And in that they did a superb job. So once the CAD work was all done, I printed them off, and here's a picture of them on the printer bed, quite literally hot off the printer bed. And here they are, ready to be rammed up in the drag. Now, the 2 items on the left indicated are just to take up a bit of extra space, because I just hate doing a cast and wasting space, and I try and do as many castings all at once as I can. Now, here on the left you can see the 2 blind risers and the 2 orange risers, which are conventional style. Now, there's nothing stopping me using the conventional risers instead of the blind risers, but I just chose to do it a different way, me being me for some reason or other. The other 2 bits of castings were purely spare aluminium billets that I used for machining bits and pieces up, and tool holders and whatever. Now, here I was just tidying up the mould and putting in the gates and the runners, and this is the casting all ready to be done. Right, the casting as it came out, as it happened, my blind risers had moved slightly. Didn't make any difference. It was just a slightly wrong approach in the first place anyway. But the good castings, and you can see the shrinkage on top of those blind risers. Now, when I obviously designed this, I designed it in a casting point of view, and didn't really pay too much attention to how I was going to hold it while I machined it. And that's just something that I've got to learn as I go, making things to be held during machining isn't something normally I have to think about. I'll leave that for other people to do. But since I'm now trying to do as much in-house as I can, I had to adapt to what I'd got. It's going to be a learning process, that one. Also, the problem is that because you're only making 2, you don't really want to go to the trouble of making tool holders, component holders. So in that respect, I used what I had already to try and hold it while I did some of the machine work. It's a quick slow motion clip. I have got so much of this film footage. In fact, there's this project I acquired God knows how much film footage in total. So I think I might put a separate video up on just the slow motion alone. So now you can see what I just did. So I'm going to machine this top surface, do the same on the other one, and then I've got a nice dead flat surface to turn it over and machine the bits off, hopefully. And what I might also do is might just machine these bits here, and I'll tell you what, no point in machining those bits there at all if it won't go in the vise. And I'm not so sure it's going to. Oh, just about. Okay, so that's good. So I might just put just a little flat on there, just enough to grip it. So let's go. Now you can see I'm just machining off the draft purely and simply so I can hold this in a moment in the vise. I couldn't use the original holes to hold the component down because I'm not actually drilling those. They're doing that when they come to fit them. Purely and simply because the modelling component that I had to measure off was broken, so we didn't have a very good accurate measurement for the hole placing. So all I'm doing is machining off the top block now because it's of no use. Like I say, in hindsight, I think I would have designed this slightly different, but there you go, learning process. I might cover that in the CAD video. Now, as you can see, I'm holding this purely and simply on the flats that I machined on the sides. No supports underneath. I took a bit of a gamble to do this, but I haven't got any parallels, not thin enough to do this anyway. Something I might just have to make. I just might make myself bits of tin really. But it worked well enough, and I was only taking very light cuts. And before anybody says anything, yes, the compression on the sides has deformed it slightly during machining. Now I measured it at the end, and it was only like 0.3 out of roundness, so more than well within what we needed. Now this is just the final last bit of machining before it's done and finished, and it's purely and simply to put in like a 1mm deep lip that's sealed on the tube. So there we have it, 2 spacer blocks for the 2 engines, and they came out pretty well. This is the engine, and you can see where it goes, and that's how it's mounted. So thanks very much for your time. I will say that I do put quite a bit of effort into these videos. I'm not brilliant at it. I try and fit it in with doing what I'm doing. As you can see, when I am filming, it is a right pain, especially when I've got 2 cameras on the go at once. But anyway, thanks for your time. Please come back, make sure you subscribe, ring that bell, blah de blah de blah. See you again soon. Ta-da.